Survivability kits, Tusk, for Abrams main battle tanks supporting operations in Iraq, under a US $45 million contract. Deliveries were expected to be completed by April 2009. 97. Under a separate order, the U.S. Army awarded General Dynamics Armament and Technical Products, DATP, US $30 million to produce reactive armor kits to equip M1A2S. The reactive tiles for the M1 will be locally produced at DATP's Burlington Technology Center. 97. Tiles will be produced at the company's reactive armor facility in Stone County Operations, McHenry, Mississippi. In December 2006, the U.S. Army added counter-improvised explosive device enhancements to the M1A1 and M1A2 Tusk, awarding GDLS $11.3 million contract, part of the $59 million package mentioned above. In December, GDLS also received an order, amounting to around 40% of a US $48 million order, for loaders thermal weapon sights being part of the Tusk system improvements for M1A1 and M1A2 Abrams tanks. 97. Active Protection System. The Trophy Active Protection System, APS, was installed and tested on a USMC M1A1 Abrams in 2017. In addition to the armor, some USMC Abrams tanks were equipped with a soft-kill active protection system, the N/VLQ-6 Missile Countermeasure Device, MCD, that can impede the function of guidance systems of some semi-active control line of sight, SAC-LOS, wire and radio-guided anti-tank missiles, such as the Russian 9K-11 Forschum, and infrared homing missiles. 98. The MCD works by emitting a massive, condensed infrared signal to confuse the infrared homing seeker of an anti-tank guided missile, ATGM. However, the drawback to the system is that the ATGM is not destroyed, it is merely directed away from its intended target, leaving the missile to detonate elsewhere. This device is mounted on the turret roof in front of the loader hatch, and can lead some people to mistake Abrams tanks fitted with these devices for the M1A2 version, since the commander's independent thermal viewer on the latter is mounted in the same place, though the MCD is box-shaped and fixed in place as opposed to cylindrical and rotating like the SIT. In 2016, the U.S. Army and Marine Corps began testing out the Israeli Trophy Active Protection System to protect their Abrams tanks from modern RPG and ATGM threats by either jamming with ATGMs or firing small rounds to deflect incoming projectiles. 99. The Army planned to field a brigade of over 80 tanks equipped with Trophy to Europe in 2020. 100. It is planned for up to 261 Abrams to be upgraded with the system, enough for 4 brigades. 101. In June 2018, the Army awarded Leonardo Doctors, U.S. partner Trophy's designer Rafael, a $193 million contract to deliver the system in support of M1 Abrams. Immediate operational requirements. 102. U.S. Army M1A2 SEPV-2 Abrams tanks deployed to Germany in July 2020 fitted with Trophy systems. Deliveries to equip 4 tank brigades were completed in January 2021. 103. Armament. Primary. M68A1 rifled gun. The main armament of the original model M1 and M1IP was the M68A1 105mm rifled tank gun, firing a variety of armor-piercing fin-stabilized discarding sabot, high-explosive anti-tank, high-explosive, YT phosphorus rounds and an anti-personnel, multiple flushed, round. This gun used a license-made tube-off British Royal Ordnance L7 gun together with the vertical sliding breech block and other parts of the U.S. T254E2 prototype gun. However, It proved to be inadequate. A cannon with lethality beyond the 1.9 mile, 3 kilometers, range was needed to combat newer armor technologies. To attain that lethality, the projectile diameter needed to be increased. The tank was able to carry 55 105mm rounds, with 44 stored in the turret blowout compartment and the rest in hull stowage. M256 smoothbore gun. M1 Abrams during a U.S. Army firing exercise, displaying internal crew cabin operations, and M1A1 fires its main gun in 2019. The main armament of the M1A1 and M1A2 is the M256, a 1120mm smoothbore gun, designed by Rheinmetall AG of Germany, manufactured under license in the US by Waterfly at Arsenal, New York. The M256A1 is an improved variant of the Rheinmetall 120mm L/44 gun carried on the German Leopard 2 and all variants up to the Leopard 2A5, the difference being in thickness and chamber pressure. Leopard 2A6 replaced the L/44 barrel with a longer L/55. Due to the increased caliber, only 40 or 42 rounds are able to be stored depending on if the tank is an A1 or a 2 model. Elevation, 9 to plus 20 degree. The M256A1 fires a variety of rounds. The primary APFSD round of the Abrams is the depleted uranium M829 round, of which fewer variants have been designed. M829A1, known as the Silver Bullet, saw widespread service in the Gulf War, where it proved itself against Iraqi armor such as the T-72. The M829A2 APFSD round was developed specifically as an immediate solution to address the improved protection of a Russian T-72, T-80U or T-90 main battle tank equipped with Contact 5 explosive reactive armor, ERA. 104. Later, the M829A3 round was introduced to improve its effectiveness against next-generation ER-equipped tanks, through usage of a multi-material penetrator and increased penetrator diameter that can resist the shear effect of K5 type ERA. Development of the M829 series is continuing, with the M829A4 currently entering production, featuring advanced technology such as data link capability. 105. The Abrams also fires high-explosive anti-tank warhead-shaped charge rounds such as the M830, the latest version of which, M830A1, incorporates a sophisticated multimode electronic sensing fuse and more refragmentation that allows it to be used effectively against armored vehicles, personnel, and low-flying aircraft. The Abrams uses a manual loader, who also version of which AM1A1 firing its main gun as seen from the loader hatch. The M240 is visible.
Yes, that happened when I get sleepy. I clicked with the mouse by mistake. Just read from the top again.
The Abrams also fires high-explosive anti-tank warhead-shaped charge rounds such as the M830, the latest version of which, M830A1, incorporates a sophisticated multimode electronic sensing fuse and more refragmentation that allows it to be used effectively against armored vehicles, personnel, and low-flying aircraft. The Abrams uses a manual loader, who also provides additional support for maintenance observation post /listening post, op/LP, operations, and other tasks. The new M1028 120mm anti-personnel canister cartridge was brought into service early for use in the aftermath of the 2003 invasion of Iraq. It contains 1,098 3/8-inch, 9.5mm, tungsten balls that spread from the muzzle to produce a shotgun effect lethal out to 600 meters, 2,000 feet. The tungsten balls can be used to clear enemy dismounts, break up hasty ambush sites in urban areas, clear defiles, stop infantry attacks and counter-attacks and support friendly infantry assaults by providing covering fire. The canister round is also highly effective breaching round and can level cinder block walls and knock man-sized holes in reinforced concrete walls for infantry raids at distances up to 75 meters, 246 feet. 106. Also in use is the M908 obstacle reduction round. It is designed to destroy obstacles and barriers. The round is a modified M830A1 with the front fuse replaced by a steel nose to penetrate into the obstacle before detonation. 107. The U.S. Army Research Laboratory, ARL, conducted a thermal analysis of the M256 from 2002 to 2003 to evaluate the potential of using a hybrid barrel system that would allow for multiple weapon systems such as the XM1111 mid-range munition, airburst rounds, or XM1147. The test concluded that mesh density, number of elements per unit area, impacts accuracy of the M256 and specific densities would be needed for each weapon system. 108. In 2013 the Army was developing a new round to replace the M830/M830A1, M1028, and M908. Called Advanced Multipurpose, AMP, round. It will have point detonation, delay, and airburst modes, Thruffen ammunition data link and a multi-mode, programmable fuse in a single munition. Having one round that does the job of four would simplify logistics and be able to be used on a variety of targets. The AMP is top effective against bunkers, infantry, light armor, and obstacles out to 500 meters, and will be able to breach reinforced concrete walls and defeat ATGM teams from 500 to 2,000 meters. 109. 110. Orbital 8 Equus awarded a contract to begin the first phase of development for the AMP XM1147 high-explosive multipurpose with tracer cartridge in October 2015. 111. In addition to these, the XM1111 mid-range munition chemical energy was also in development. The XM1111 was a guided munition using a dual-mode seeker that combined imaging infrared and semi-active laser guidance. The MRMCE was selected over the competing MRMKE, which used a rocket-assisted kinetic energy penetrator. The CE variant was chosen due to its better effects against secondary targets, providing a more versatile weapon. The Army hoped to achieve IOC with the XM1111 by 2013. 112. However, the mid-range munition was cancelled in 2009 along with future combat systems. 113. Secondary. The Abrams tank has 3 machine guns, with an optional fourth .50 cal. 12.7 mm M2HB machine gun in front of the commander's hatch. On the M1 and M1A1, this gun is mounted on the commander's weapons station. This allows the weapon to be aimed and fired from within the tank. Normal combat loadout for the M1A1 is a single 100-round box of ammo at the weapon, and another 900 rounds carried. The later M1A2 variant had a flex mount that required the tank commander to expose his or her upper torso in order to fire the weapon. In urban environments in Iraq this was found to be unsafe. With Common Remote Operated Weapons System, CROWS, add-on kit, an M2A1.50 caliber machine gun, M240, or M249 saw can be mounted on a CROWS remote weapons. M1A1 firing its main gun as seen from the loader hatch. The M240 is visible lift while the M2 is visible right. Platform. similar to the Protector M151 remote weapon stationist on the Striker family of vehicles. Current variants of the Tank Urban Survival Kit, Tusk, on the M1A2 have foregone this, instead adding transparent gun shields to the commander's weapon station. The upgrade variant, called the M1A1 Abrams Integrated Management, AIM, equips the .50 caliber gun with a thermal sight for accurate night and other low visibility shooting. 114. A 7.62mm M240 machine gun in front of the loader's hatch on ASC-8 mount, seen at right. Some of these were fitted with gun shields during the Iraq War, as well as night vision scopes for low visibility engagements and firing. This gun can be moved to TC's position if the M2.50 cal is damaged. A second 7.62mm M240 machine gun in a coaxial mount, i.e., it points at the same targets as the main gun, to the right of the main gun. The coaxial MG is aimed and fired with the same computerized firing control system used for the main gun. One earlier M1 and M1A1's 3000 rounds are carried, all linked together and ready to fire. This was reduced slightly in later models to make room for new system electronics. A typical 7.62mm combat loadout is between 10,000 and 14,000 rounds carried on each tank. Optional, a second coaxial .50 cal. 12.7mm M2HB machine gun can be mounted directly above the main gun in a remote weapons platform as part of the XAM, counter-sniper anti-material mount, package. Aiming. A view of the gunner's station, bottom left, and commander station, top right. The Abrams is equipped with a ballistic fire control computer that assesses user and system supplied data from a variety of sources to compute, display, and incorporate the three components of a ballistic solution: lead angle, ammunition type, and range to the target to accurately fire the main gun. These three components are determined using a laser rangefinder, crosswind sensor, a pendulum static cant sensor, data concerning performance and fly characteristics of each specific type of round, tank-specific sight alignment data, ammunition temperature, air temperature, barometric pressure, a muzzle reference system, MISIS, that determines and compensates for barrel drop at the muzzle due to gravitational pull and barrel heating due to firing or sunlight, and target speed determined by tracking rate tachometers in the gunner's or commander's controls handles. All of these factors are computed into a ballistic solution and updated 30 times per second. The updated solution is displayed in the gunner's or tank commander's field of view in the form of a reticle in both day and thermal modes. The ballistic computer manipulates the turret and a complex arrangement of mirrors so that all one has to do is keep the reticle on the target and fire to achieve a hit. Proper lead and gun tube elevation are applied to the turret by the computer, greatly simplifying the job of the gunner. The fire control system uses this data to compute a firing solution for the gunner. The ballistic solution generated ensures a hit percentage greater than 95% at nominal ranges. Either the commander or gunner can fire the main gun. Additionally, the commander's independent thermal viewer, SITV, on the a second armored cavalry regiment soldier assisting in the critical job of boresighting the alignment of all tank sights to the center of the axis off the bore of the main gun on an M1A1 Abrams in Mosul, Iraq, in January 2005. Hand signals enable a gunner inside the tank to train the main gun onto a boresighting target. M1A2 can be used to locate targets and pass them on for the gunner to engage while the commander scans for new targets. If the primary sight system malfunctions or is damaged, the main and coaxial weapons can be manually aimed using a telescopic scope boresighted to the main gun known as the gunner's auxiliary sight, GAS. The GAS has two interchangeable reticles, one for high explosive anti-tank, heat, and multipurpose anti-tank, that, ammunition and 1 for armor-piercing finstabilizer discarding sabot, APFS, and smart target activated fire and forget, staff, ammunition. Turret traverse and main